Hi, my name is Aiko.
And my name is Pajka.
And for our topic for ProjectCS Girls, we chose a safer world.
Specifically, we decided to explore terrorism and the danger explosives pose.
The effect of terrorism is astronomical. The most common method of terrorism is bombing or explosives.
As you can see, the cost and fatalities related to this makes it a crucial problem to solve.
These are some examples of the aftermath of the bombings. This is the bombing at the World Center.
And this is the bombing of Oklahoma, the concert bombing of Paris, the bombing of the airport in Brussels, and lastly, the bombing of the Boston Marathon.
These are some examples of existing explosive sensors. There are biological sensors like dogs and bees. However, the cost and time that these take to train are overwhelming.
There are also trace and bulk detection methods like X-rays at airport security. These, however, are not entirely reliable.
Our solution is based on emerging and present nanotechnologies, including ones that have carbon nanotube applications.
Some applications of these emerging technologies include being anti-corrosive, waterproof, they detect strain, they're paintable, they are nanosensors and ink packaging sensors.
Our solution, the explosive sensing paint, is purposed to detect and terminate explosives before they can harm anyone. The goal is to detect, identify, and respond.
We had many considerations to bring into our attention, such as our device had to be cheap, portable, small, lightweight, user-friendly, accurate, sensitive, reusable, real-time, using low power.
Our invention is a nanopaint, or coating, comprising of a chemical nanosensor array made up of single-walled carbon nanotubes, which are designed to interact with and detect ambient gas or vapor molecules coming from different explosives, using drain and source interdigitated electrodes, silicon oxide, and silicon, as they act as a conductor and an insulator. This device is able to work.
A secondary device would wirelessly transmit the sensor signal data remotely to a computer program which analyzes and interprets the data to determine the identity of the chemical being sensed, and therefore the explosive, using a database of predetermined conductance values.
As we have mentioned, we learned that single-wall carbon nanotubes have high conductivity, and because they are made up entirely of surface atoms, they are ideal materials for the electrical detection of trace chemical vapors or gases, where single-wall carbon nanotubes can act as a sensor and a transducer.
The detection is dependent on the chemical interaction of the single-wall carbon nanotubes and the analyte chemical gas or vapor, because of electrons being transferred between them, which results in a change of conductivity of the single-walled carbon nanotubes, which is what we're measuring.
Our explosive sensing paint, or ESP, uses chemical nanosensor technology, which transmits information wirelessly to the computer. Then, the software uses an algorithm and pattern recognition to identify the chemical explosive.
The impacts of our solution is great. This system may be used to also detect drugs, biological weapons, environmental toxins and pollutants, smoke, and carbon monoxide. Our solution could save many lives and possibly stop more events from occurring.